Test.
Hello, Ole. Please take a seat. We are starting in 1 minute. Okay, so maybe I can just introduce, this is going to be part 2 of the SDMX in Action session. So we have Petra Merles from the National Bank of Belgium is going to chair the session. Petra, over to you.
Welcome everybody to the second part of SDMX in Action. There is an echo. Closer? Okay. I'm sorry for this. So welcome to the second part of SDMX in Action, where we will continue sharing experiences from different institutions. There is an echo here, no? Oh, okay. So this morning the focus was mostly on statistical institutions, and in the second part the emphasis will be more on the financial and the administration world, with shared experiences from several central banks, the World Bank, the BIS, and the statistical department of the Italy Marche region. Bruno already mentioned it yesterday. Central banks are a kind of special creatures in the SDMX world. We're both on the producers and on the user side, and also the same challenges as we all face, like managing the metadata data, avoiding double use, modeling harmonization. And the use of SDMX was not common for central banks, but now we see an evolution towards standardization also at this level for disseminating reporting, but also upstream production. The first presentation is from Stefano Pamianco and Almir Delic from the ECB, and they will guide us through their space project and the evolution in AI.
Thanks a lot, Petra. Good morning, everyone. So yes, we are going to drive you through the space project adventure that we have at the ECB and its interoperability with the SDMX standard. So SPACE is a core system for the ECB to collect, compile, disseminate, and publish data. It serves almost 1,000 users in the ECB, and it contains already, after a few years of production, billions of observations in SDMX stored in the system. We collect on a daily basis hundreds of SDMX files, and we have more than 150 business processes on the system already running. So space is a SDMX driven system, meaning that SDMX permeates the whole infrastructure. We are relying heavily on SDMX registry. Currently, we are using the Fusion registry, but we're planning to move to the FMR. And space provides with a layered architecture. So you can see that we have a bottom layer, which is the data storage level implemented in HBase. And this is following the approach of the GS-BPM, so providing the data in different data stages. And each stage is a DSD compliant stage, so you can only store DSD compliant data into it. The two middle layers, the microservices and the common function library, are providing the business users with a Python interface to access, manipulate, and query, store data in an easy way, so without needing to understand how complex is the underlying physical model. And the data is presented as pandas data frames, following the SDMX structure of the data, so with all dimensions, measure, and all the attributes which are needed, also metadata attached to the information. The business processes are therefore implemented in Python, so business users are actually building their own processes in Python, and they can orchestrate all of them to automate processes using a workflow manager, which is Camunda. We also offer an Excel plugin, which was very demanded by our economics colleagues because they like to have Excel anyway. So, but it is still SDMX, looking like an SDMX information, so with all dimensions and measures and attributes. What we would like to, of course, the whole platform, as you have seen, it's SDMX, meaning that at all stages the data is defined into the DSD. You cannot store any data which is not in the registry, and we also govern the data exchanges using provision agreements, for example, constraints, code lists. So the business has a clear understanding of what they are doing because they are using the standard extensively, and they are provided with a self-service system which can be used for them to program, to define their business process, to manipulate the data, and to be, let's say, understanding, being aware of SDMX as a tool, not only as a data exchange technical standard. So this was quite, let's say, a change for them because they were not used to know SDMX so deeply, but I think we reach a level where they are more independent in defining their own data. So the space journey, of course, doesn't stop because new technologies are arising, and Almir now will present to you what we are doing currently.
Thanks a lot, Stefano. So we have space is now in production, and we have all of our users, they're starting to join the platform and then to use it. And what we thought would be quite useful is to have some service to support them. Because as you heard, we use, so the main component which they interact with is this Python custom library, which has a few thousand functions. And they need some support how to use it, how do they disseminate, how do they compile the data, and so on. So what we want to have is a service where they can, of course, query in natural language, and they receive SDMX-aware space Python code. It's a self-service solution, of course. It means that users can be independent from the space support team, and also just as important from having to ask their colleagues all the time, how do I do this, how do I do that on space? It aims to improve efficiency and proficiency with the space Python library, which would then help us to support a successful space platform adoption. And it also democratizes the access to the platform, meaning that even novice users would be able to use the more advanced functions on space if they have space AI to support them. So we use the typical RAG approach. We build an index. It's mainly built from this space Python library. So we use the doc strings, and it also looks at the function signature and things like this. So we have the central library, and then we have about 100 repositories which implement custom processes based on the central library. So we basically build this RAG based on this, but we don't support all of it's between 3,000 and 5,000 functions. We support only the 300 plus most commonly used functions, because this is where we expect is that the users will want their answer from anyway. So where we are now is we have, one problem we have is, of course, with evaluating how accurate it is. And now we use expert reviewed results. Currently we're at 69% accuracy rate, meaning that the Python code that Space provides, it's correct from the beginning to end. The whole block of code, and it also accomplishes exactly what it's supposed to accomplish. And then we also have this automatic evaluation, which can only evaluate is the expected function in the provided answer, so that at least the expected function is correctly identified. So there we're at 91%. Challenges we have are, of course, this changing AI landscape. We have different models, we have different versions. Now we have AI agents coming, so we're also experimenting with all of those things in parallel to wanting to go to production. The other challenge, of course, is bringing the solution to production. So as everyone else, there are many things, we have many prototypes and so on. We're still not there, but we hope to be there, let's say, early next year. And as the next step, what we also want to do is, so now currently it's based on Confluence pages and these doc strings and so on. What we want to do is also to feed it the internal SDMX metadata, so all of our DSDs and data flows and code lists and so on. Because, for example, this is quite useful because then the users can also say, I would like to create, for example, an aggregation across all the EU countries in my data set, M&A or QSA or whatever. And then the service would be able to understand and to pick out the EU countries to find the correct dimension and to create this aggregation in the Python code. So this already works now, but it's almost accidental because we have some examples in Confluence pages and so on. But we think if we can feed it all of the metadata, then it will be able to correctly identify which data set, which dimension, and so on. We're also working on developing some kind of automated evaluation. This is also a big challenge, and we don't really have a solution for this yet. So maybe if someone has suggestions later, I'll be happy to hear them. Because again, now it's all expert reviewed. So a person has to look at it every time we do an update and to really see, is it better or is it worse than it used to be? And as the next step, what we would like to do is also to have support for debugging or for improving code, because we have a user base and we also expect them to be able to write their own code, to create their own aggregations and validations and so on. And it would be useful if they could just copy their code and say, could you please improve it, or could you help me with fixing this Python error that I have on Space? And I have also a very short demo for a very simple use case. I'm not sure if it's playing or not. It is. So this is just to ask, how do I check the status of my dissemination? And then thinks about it for a little bit. And then what we want is to have a little bit of an explanation, which function you should run, which parameters you should use, what the parameters mean, and so on. And then you also have like an example output. So how much data was disseminated? Was it successful? Was it not successful? What kind of error? And so on. This is my very last slide. Thanks a lot for your attention. Thank you.
We move to the next presentation, which is given by Ibrahim Kaya, here on my left side, and he's working in the statistics department of the Bank of Malta, and he will talk about an SDMX-oriented dissemination system at the Central Bank of Malta.
Thank you, Petra. Can I get the clicker? Thank you very much. Bonjour and good morning from Malta. Today I will presenting our case study on implementing the SDMX-oriented dissemination system at the Central Bank of Malta. Here is a quick overview of today's presentation. I will start with an introduction, then discuss our current practices on data dissemination. Next, I will walk you through the SDMX implementation process, this including the migration steps and the tools. I will share a study case, and finally, I will conclude my presentation with our way forward. As introduction, the Central Bank of Malta is responsible for collecting and disseminating a very wide range of statistics, including the banking, monetary, financial markets, and the payment system statistics. But in this case, the compliance with the international and the European standards is essential. We use the SDMX information model for data transmission, but our internal information model is different. So we need to convert our data to the SDMX system with a very different system. So practically it's very important to using the SDMX in all phases. About our current dissemination process, we have 3 different approaches. One of them are the website. In the website, we provide static Excel files, which are not compliant with the SDMX information model. But also we give European Central Bank statistical data warehouse links. So practically these links and the information in there is SDMX oriented. So for the website, we can say that we are partially estimate oriented data dissemination. For data transmission, obviously we use the XI to send the data to the ECB and we use the different web services for sending data to the IMF, and these are obviously SDMX oriented. Our final stakeholder holders are different national authorities in Malta. We send our data to these national authorities via SFTP, and these are not SDMX compliant. So, what should we do? First, we describe the business needs in here. Is information needed as aggregated or non-aggregated level, or the users which users that we should provide the information? Yeah, for example, for the public, yes, we use our websites and partially SDMX oriented, but for the Central Bank of Malta internal use, such as the financial stability, the other issues, we use our internal system, and this system is not SDMX compliant. So the other one is the national authorities that we send the data. So practically we first describe the business needs. After that, we match our current information model with the SDMX. After the matching, we get information. If the data flows are directly matching, we use the data flows for example, for the ECB and IMF, we use directly use them in our SDMX implementation plan. If not, we have to convert our data to the SDMX format. So what is the migration steps in here? The migration steps is the conversion of the data dictionaries to the SDMX, and also with the data sets. If it's not compliant with the SDMX, then what we do? We first change our elements in our internal system is elements. We convert to the code list. We have structure items. It's very similar to the DSD. We converted them. After that, we create our categorization and data flows. And we did this conversion with our scripting, and it's automated process. If some new elements or the structure item is on the system, our system automatically convert to SDMX. What is our tools for the SDMX implementation? We evaluated 2 main tools through the CBM perspective. The option one is the open source and runs on Linux and has strong community support, but requires complex authentication and custom dashboards. Option 2 is also open source, but runs on the Windows, has less community support, but offers a graphical user interface for metadata management and simpler authentication. Both options provide visualization capabilities. For our study case, we focused on the interest rate statistics, both aggregated and non-aggregated level. Aggregated data sets are medium scales. It means that almost 10,000 observations, while the non-aggregated are large scales. It's more than the 10 million rows. And we defined different data flows for and DSDs for public, Central Bank of Malta internal use, and sharing with the national authorities. So practically we have 3 different DSDs, we have 3 different data flows in Full aggregated and selected non-aggregated data is using common data sets, common data structures, code lists, not the data structures, the code lists. And this is our case. As a conclusion, we plan to further investigate option 2 because our team has strong expertise with Windows environments. The metadata management graphical user interface meets our business needs. That's important. And the dissemination tool is easy to manage for both internal and external users. We will conduct further tests with internal users and the national authorities to ensure the system meets all the requirements. And thanks for your attention.
Okay, thank you. The next speaker from Malta, we move to Armenia. Diana Afyan from the Central Bank of Armenia will give some insights on the behavioral survey data through SDMX.
And first I want to thank you and to organizers for this opportunity. And I believe our experience can be some kind of motivational for other central banks who I know you know the behavior data are very important for the policymakers. And I'm going to share experience how we bridge survey gaps and how we use the data from the inflation expectation surveys to cover the gap we have in the consumer confidence index. And we did this using the SDMX. So I want to do some kind of small introduction. So I represent the statistics department of the central bank, and our division is responsible for conducting sample surveys, and we provide behavior data to the policymakers, and they do their decision based on this data and mostly on the real sector of the economy. So central bank calculates consumer confidence index starting from 2011, and we have some data gap for 3 years, and the gap is due to we decided to transfer to migrate our data, CCI data, to the American University of Armenia. It was a case we were inspired by the case of University of Michigan. So we decided that it will be better when the independent academic unit will do consumer confidence index calculations. And so we faced some kind of problems because of our revolution. We have some elections, COVID, and 44-day war. And during that 3 years, we have a huge data gap in the CCI. And I believe most of you know how the policymakers in the central bank work. They just request data, and you should do it yesterday and as fast as possible. And you should do some kind of creative solutions. You should act like superheroes. And we have a huge problem with it because we should find how to how to cover this gap, because it's very important to have the historical comparisons. The statistics is fragmented, and there is no way to do some kind of modeling and forecasting using this data. So what we did, so when we organized the migration of the calculation of CCI, the target was the American University of Armenia should do this calculation as much as possible the same as we did. So actually we used SDMX without realizing what we were doing SDMX during the migration, and this was kind of our safe harbor because it helps us to have a very good standardized and harmonized data from both sides. And you see we asked ourselves, you see the gap, so data is end very high and start from very low, and it was some kind of problem to understand if it's due to methodology or due to some economic changes. And as we have very good standardized and harmonized data, so we can say that it's not due to methodology. And what we did, we also have inflation expectations survey, which our division also did do, and I hope we will do it for many years. So we started map the CCI components with the inflation expectation survey components, and we use it some kind of as proxy to cover the gap. So you can see there are components like economic outlook and past future price expectations, and we use the logic like it's the same. And in this slide you can see that many questions are identical, many are very similar, so we have some kind of a very good percentage of consistency, and the difference is because of the detailed data we have or we don't have. So as much as detailed as the consistency is better. So this is how the standardization and harmonization works and how we use the SDMX codes. So we try to fit it with the ECB and other standards. So because our next step is we are going to provide this data also to international organizations, and it's very important to have the same metadata and the same methods and standards, so we can fit also to international platforms. So this, you can see how it helps us, because there are some small citations from our annual reports, policy reports, because the policymakers started to use our data, and we used to provide some kind of cross tables and cross section data using both surveys. So these are benefits and how it's we enhanced our analytical value using these two surveys. And we also believe that we can go to the international compatibility. Our development roadmap is we want to make more an advanced pipeline to provide some technical part, because now so actually I'm not very familiar with the technical part. I'm a statistician, but I know what our IT partners and partners from the American University of Armenia, they use free applications from Eurostat to make conversions and other transformations to use the technical part. And I also want to thank our American University partners for the good cooperation in this term. So this is the final summary. With SDMX enables us to harmonize data and the field behavior gaps we have. So this kind of proxy methodology connects two behavior data sets together and help us to do more analytical research. So I hope that our framework and experience will be replicable for other countries, and I'm open to any discussions, and thank you for your attention.
Thank you, Diana. Moving to the last presentation of the first part, and then we have a quick question and answer tour, and then we change the speakers. So we have a joint presentation between Bank of Greece and D1. Bank of Greece is represented by Kostas Polychronopoulos, and D1 is represented by George Verouchis. So they will talk about the Gen AI assisted structural metadata generation for Bank of Greece internal data hub. floor is yours.
Thanks, Petra. Good morning, everyone, and thank you for having us today. Together with Mr. Verouchis, we'll be presenting READ and DocuMind. READ is Bank of Greece's SDMX-based internal data hub, and DocuMind is the GenAI microservice that facilitates non-SDMX data ingestion. Moving on, I may skip some of the bullets on the slides in the interest of time. If you'd like me to expand on something, let me know in the Q&A session or approach me later. I'll start with READ, and George will follow with DocuMind. So READ stands for Research and Economic Analysis Database, and in terms of data architecture, it's a data hub offered for internal use, so not a service available to the general public. As its name implies, it's meant to serve research and analysis purposes that the bank's economists expressed, and in particular alleviate pain points in their day-to-day work regarding accessing data from various sources and getting updates and revisions that would then feed downstream to their analysis, reports, etc. In a way, they needed to focus on their core work, meaning research, analysis, policy, and wanted assistance with a dull part of gathering the data for them. So what we ended up with, what READ offers currently, is a unified access to selected data published by various organizations from national to international level, categorized across dimensions such as the providing organization, the subject area, or the publication eventually feeding into, automated data updates, so for example, getting the daily exchange rates automatically, email alerts for new or revised data to the users, and the facility to easily retrieve the updated time series and feed further analysis downstream. Usually this involves Excel. Well, up to now there has been no mention of SDMX, right? That's because our economists did not ask for SDMX and probably do not care whether the enabling technology is SDMX. And this is where we, as, let's put it, as SDMX savvy IT come into place. In fact, the nature of the data requested, predominantly macroeconomic statistical data, was a good fit for SDMX. And what else was convenient? The request for a unified access fits very well with the systematic approach the SDMX information model offers. And moving further down the slide, you'll probably recognize the SDMX resources that we picked to fulfill the goal and the service offering. What I want to highlight, though, is the main technical challenge for READ, having to retrieve data from various providers and in various formats. On the SDMX provider side, the TCK, the Test Compatibility Kit, proved helpful in assessing which part of the standard works for which provider API. But when it came to ingesting non-SDMX data, such as Excel, PDF, or even images in some cases, part of the challenge lies in parsing the original source correctly, but more importantly, in our case, coming up with the necessary SDMX metadata so that the non-SDMX data fits into our SDMX information model. And this is where DocuMind comes in, and George will explain how in a minute. Just overall, the main point I want to make here is that the SDMX offering can as well cater for needs where the name SDMX is not spelled out right up front. So for example, when we're discussing reporting or dissemination needs where the standard is a requirement. Moving on to, let's say, the recipe that we used to put all the above ingredients together, you'll notice on the slide there is not much of a novelty. What worked for us has worked in many other cases as well. And closing my part, the key takeaway from our experience at the Bank of Greece is that the SDMX community and the ecosystem around it has lowered significantly the entry barrier in embarking on an SDMX-based data project. I can't tell you how many times I've heard from colleagues starting the SDMX at its earlier stage when it was called just MES. If only I had these tools when I started with SDMX. And now I'll hand over to George, who will present you DocuMind.
Thank you, Petra. Good morning, everyone, and thank you for having us today. Together with Mr. Verouchis, we'll be presenting READ and DocuMind. So READ is Bank of Greece's SDMX-based internal data hub, and DocuMind is the GenAI microservice that facilitates non-SDMX data ingestion. In fact, the nature of the data requested, predominantly macroeconomic statistical data, was a good fit for SDMX. And what else was convenient? The request for a unified access to selected data from various organizations from national to international level, categorized across dimensions such as the providing organization, the subject area, or the publication eventually feeding into, and more importantly, Thank you very much, Kostas. So DocuMind is a software that facilitates business users to create SDMX-ready metadata and data files. So the first pilot that we created was the transformation of semi-structured or completely unstructured data sets, such as the European Economic Forecast, issued in a PDF format from the European Commission. So I don't know if you have ever seen this PDF. It's consisted about 200 pages, and it includes more than 50 tables. So one of the main challenges that we face in this project was how we can create accurate, precise, and trustworthy SDMX files. What we did is to create an application based in Python that uses Azure AI, more specifically ChatGPT 4o and Document Intelligence Service, in order to create those very SDMX artifacts. So the mechanism includes, first of all, a ground and knowledge service, which is actually a RAG of existing SDMX artifacts. So for example, an NSA service most probably would like to based on Eurostat artifacts, and a central bank based in Europe most probably would like to based on ECB SDMX artifacts. So we adapt the grounded knowledge based on the provider needs. We have also configured some SDMX instructions and predefined prompts in order to facilitate the workflow and achieve those very three standards that I mentioned earlier. Our solution was successful, and as you see on those two screenshots, we were able to successfully transform unstructured and semi-structured data files, such as this PDF screenshot, to the .stat suite platform, along with those very metadata information. One of the most significant key features in our workflow was that we were able to keep the user into the loop. So the user has full control of the workflow. So he can essentially interact constantly with the data process transformation. He can select, the user can select the table, the system can capture it, can suggest which is the preferred table from the original files, and then user can enter into a loop of feedbacks during the transformation of each artifact. We have separate stages. We start with the code lists, then we go to the concept schemes, the full DSD format, the data flow, and then we conclude with the final data file. So far, we have successfully transformed more than 20 data flows into the Bank of Greece .stat suite installation. And I will be very happy if you come to our booth after this presentation to discuss more technical details to this very exciting journey with the Bank of Greece. Thank you very much.
Okay, thank you. So we can take now questions for these speakers. A lot of questions. I don't know who was first, so...
Thank you. This is Sutom from Milo again. I have questions for colleagues from ECB. It's about your AI journey. I think it's wonderful that you mentioned about the RAG. So I'm interested about, particularly on, the specifications, how you choose the AI model and also the database storage, and just the rough estimates of one query, like at the cost level. And also, another question is about, have you ever compared this with some existing solutions like Cloud Code or Copilot, or some other considerations why this is not suitable for your solution? Yeah, thank you.
So it's been, sorry. We can continue now. It's been a bit of a journey for us because we started on Azure and then we used ChatGPT. And then we were told not to use this anymore. We had to switch to a different platform and so on. And then we moved to AWS and Bedrock, and there we don't have ChatGPT. But we had a selection of different models, and I think now we use Claude. It's basically down to testing. So we test what works best, and also we know Claude is one of the best models for code. So this is what we use in the end. I think this answers the model approach. For cost, I don't remember the numbers, to be perfectly honest. It was very low because we have one micro instance just to host a website. This is very cheap, and then I think we do 6 or 7 round trips to the service per each query. I think we were maybe a few, so we estimate that we have about 200 users, and each of them has a few requests per day, and I think with this it was a few hundred, like 300, 400, 500 a month. So this is the estimated cost, and we would have to see once we're in production how much it actually costs. Copilot, we just have at the ECB since, I have it since 2 weeks or 1 week. It is indeed, it's quite capable, and it can do some similar things also to what we want to do. It's more integrated in the IDE. So also our users are economists and statisticians and so on, and they don't really use IDEs. They're not developers strictly. Maybe this will change in the future, but at the moment at least. And many of these things are basically used. So how do I get the status of my dissemination? How can I check which files arrived yesterday from the UN, from Eurostat, and so on? And it gives an answer, and then you can just copy paste it. We have indeed, I think maybe for the power users they could use probably Copilot. But we wouldn't have to see how do we feed it all of this context with the SDMX metadata and so on. This is not immediately obvious. And it was also, I think, one of the challenges I wrote. This landscape is constantly changing. So when we started, it wasn't much choice. We had ChatGPT, and now everything is different. We have so many models. There are dozens of models. There's Copilot this year. Now we have AI agents. I watched a presentation by AWS, by Amazon, saying with AI agents, you can just tell them, here is my repository, here is all of my code, and you can answer the questions based on the repository, and you're done. I really don't know what's coming next, but we're prototyping. We try the new services, and then we see maybe next time what comes out in the presentation.
Okay. Okay, me first. Sorry. I'm Hairul from Bank Indonesia. I have a question for the colleague from ECB. In your slide of AI architecture, I really interested about the knowledge base. So could you elaborate more about how you develop the knowledge base that combine the Python code and SDMX metadata, and then how search queries from the user with LLM to retrieve the relevant information from your knowledge base? What is the methodology? Is it a knowledge graph, vector embedding, or other methodology? And how you use, what is the tools that you use to store the repository of your knowledge base? Thank you. Tools that you use to store the knowledge base in your repository.
For knowledge base, I think we use OpenSearch. We just had to switch again. There was this built-in hybrid search on Azure, which we used to use, but then we had to switch the service, so this is what we have now. This is another thing, this is constantly evolving, but it's broadly comparable, I think, in functionality. Knowledge base, I touched a little bit. We use, it's mostly doc strings, because this is quite elaborate from what we have in our library, and we use signature functions. And then we use, so there's this common library, which is reading, writing, configuring, and then there are all of the processes which use the common library. And this is also quite good pointers for the model where to find the information. And again, what we would like to include is all of this SDMX metadata, because I think this would be quite useful for the more complex features like aggregations, validations, and so on. But we haven't done this yet, so this is planned. I'm not sure how we will incorporate this, but it's on the map to enable this bit more complex functionality.
Okay, the time is limited, so I see lots of questions. Maybe we join them together and try to give a quick answer to them. Abdullah, Edgardo, there, so.
Shall I?
Okay.
So my question is on Bank of Armenia. I feel it is a great work because surveys you are bringing under the SDMX framework. So my question is about how would you model? I mean, whether it is a disaggregate level, because surveys are basically directly connecting data collecting from the users. So how did you model? Whether it is a disaggregate level or the aggregated report you are made into SDMX format. So that's my question. Thank you.
Take some more questions.
Yeah, Abdullah Ghazalov here in Statistics Division. My question is to the Bank of Greece. I think this is fascinating what you're doing because you're taking a structured and unstructured data and then basically use SDMX as the lowest common denominator using AI. My question is, do you think that after 3 or 4 iterations in a couple of years, you simply won't need SDMX anymore? You will let AI figure out your internal representations. Just feed it data of whatever format from any source, and it'll figure it out, and then it'll provide to you the analytical capability and the outputs that you need.
Yeah, thank you for the presentation. My question is also for George from D1. Not so futuristic as Abdullah, more current question. When you create the underlying structure for the table that you will disseminate, you generate a self-contained structural metadata package. That means that you generate a specific code list and concept scheme, or you are able to refer to existing concept scheme with its own code list so that you can, let's say, generate references to existing artifacts. Or if not, if you are thinking of that.
Yes, good morning, thank you. So Kamel from Africa Development Bank. I have 2 questions and I hope that will be quick. First question to ECB. You said that in GSPPM stage data, you are DSD based. So I want to know how to synchronize and move from a stage to another and how you reduce in terms of dimensionality. The second question is to colleagues from GIS, and I share the same opinion. My colleague Abdullah, is a dream to see a tool that can help us for data modeling. Since we are working with more than about 100 institutions between NSO 54, NSO, central banks, and REX in Africa. So it will be, my question is, how can I, as a mixed expert, give my opinion to improve the proposal? And if I load many tables, the system will go table by table, or will try to optimize, how to optimize this process. Thank you.
Well, it's working? Yeah, thank you. Ingo Kunert from the European Commission, Directorate General for Economic and Financial Affairs. I just have a quick comment for the colleagues from the National Bank of Greece, because we are the ones that are producing the publication that you were reading in PDF. I'm sorry we're a bit behind the curve, but actually we are, I think a few weeks ago, we've put them out in an SDMX compliant format with an SDMX API. We have not announced it publicly yet. I think we'll do that with the autumn forecast, but we've been working on that, so the data should be available in SDMX format in a moment's time. Thank you.
So thank you for the question. So first we try to do it in a more aggregate level, just to the consumer CCI and in level, but we got very low consistency, and we try to go deeper, and also we tried to the respondent levels, and as much you go deeper, as this consistency became more better. Just we have the contract between Central Bank and the American University. They provide us all the databases, and we try to find some, we do some kind of, we create some other sub-indexes which are proxy to the which one we want to get. Is it okay? The answer. Thank you.
Yeah, so on the data stages, so we follow the GSBPM in the sense that we have for each, let's say, stage of the data a different data storage. So we store the data for the collected data, then we have the processing part where we store aggregates and the indicators. Then we have the kind of integration layer where we have the pre-dissemination data, and then at the end, the disseminated data. And as you remember, maybe from the slide, there are two intermediate layers which are taking care of checking the data against the DSD, so while writing and also while reading. So we can then, let's say, make sure that the data that is stored there is actually compliant with the definitions that we have in the registry.
First of all, thank you very much for those all excellent questions. First of all, my vision is to make use of existing artifacts, not to generate different code lists, different artifacts for our needs. And to answer the first question, we will need SDMX. We will need in the future standardized formats, because AI, whatever the progress will be, I believe in the background, in the foundations of the models, will use standardized formats. For the document features, we try first to exhaust already made code lists and concept schemes for the existing providers, and only if we do not find the match, then we create our own self-contained artifacts. But for our current needs, only a few cases demanded the creation of those very artifacts. And regarding the question from the European Commission, this project started more or less 1 year ago, and we chose the European Economic Forecast as a pilot, but then we extended the workflow to a lot of different sources from various providers. So yeah, I don't know if I forgot something, but thank you very much.
If I may add on the last one, it's a pleasure to find even more SDMX sources. Our economists use the publication, this particular one, extensively, and I'm pretty sure that you know, the producer's view on the data will have a much more intuitive, extensive output as the one that we captured maybe on the user side. So it's definitely a plus to have. Maybe an unfortunate choice on our side. I don't know if we should have chosen another. But that's also the pace of the evolution. This is it. I mean, with AI and the community moving, we try stuff. We come here 1 year later. Other people have done similar stuff. Maybe we could have talked and, you know, gathered together. Anyways, I'll stop here, but thank you very much. It's exciting news. Yeah.
So we continue our session. The next presentation is from the clicker. Yeah, is from the World Bank. We have Tony Fouge and Lorena Corso with us here, and they will give us some insights in unlocking the potential of SDMX and open source for data management at scale. Please.
All right, thank you. Good morning, everyone. So my name is Tony Fouge.
And I'm Lorena Corso.
and we both work in the World Bank Development Data Group. So today we're going to talk about how we leverage the SDMX ecosystem to revamp our data infrastructure at the World Bank. So as you may know, the World Bank has been a sponsor of SDMX since pretty much the beginning of the initiative. But even though we've been publishing some data in SDMX format, we've never really been an SDMX shop producing SDMX data in-house for quite a while. And this has changed a couple of years back for two main reasons. The first one is that our legacy data system started to kind of become obsolete, and it was becoming harder and harder to support our data workflows. And the second reason is that our team responsibilities expanded, and the number of data sets that we had to manage increased. So we got in that very comfortable situation where we had to build a larger building while at the same time digging new foundations. And so we started to look at potential solutions, and the SDMX ecosystem quickly became an obvious candidate.
So leveraging the SDMX ecosystem felt like the perfect fit for our use case because of three reasons. The first one is robustness, because it's a well-known and pretty well-established standards across several international organizations and data producers. And that gave us a lot of successful stories for us to learn from other implementations. At the same time, it has a huge portfolio of systems and tools that enable us to land in a fast lane of production readiness, as it was easy for us to onboard several of these tools and systems into the World Bank ecosystem, and have a relatively short learning curve for data managers to start using them right away. At the same time, they provided flexibility for us for an implementation by phases, and to meet all the needs from our producers and users, which has also very specific requirements. And the third reason is the SDMX community, which is here present, that is constantly not only exchanging information and experience from their implementation, but also looking for constant improvement for such tools and systems, which is very important for us, and we also look to contribute back as well.
All right, so what does it look like in practice? This is a very high-level, simplified schema of a typical data workflow. So you read it from left to right. On the left in red, you have all our typical inputs that goes into our data pipelines. So the data source itself, referential metadata, and SDMX artifacts, including DSDs, data flows, or structure map. Then the next big rectangle in green is everything that is related to data ingestion, transformation, validation. As an output of that, we have a set of standardized data and metadata in SDMX format. And then this got ingested into a centralized storage system where review, publishing happens, and then it is disseminated at the end through our website and API. So we both have internal and external client for this. And as you can see, this is pretty standard, but this is nothing fancy or typical, specific to the World Bank in this. But as you'll see, as we highlight the benefits of the SDMX ecosystem for us, what is interesting is that at pretty much every stage of that process, we were able to leverage at least one component of the SDMX ecosystem.
So as I mentioned before, flexibility is being key, and thanks to the SDMX tools and framework in general, we have it throughout the end-to-end business process. One central piece for us has been FMR, which has allowed a more robust governance body in the organization, and we now have artifacts that are shared across the entire institution, that are multi-domain and multilingual, and that has also enabled further conversation and more robust analysis on how we can harmonize and maintain the content of such artifacts to be shared and fully reused in the future. At the same time, we're also focusing on referential metadata, and we have been using the metadata editor, which is an in-house development to capture referential metadata. And as someone mentioned before, referential metadata is something that we cannot harvest easily, not from AI, not from some other like documents or resources. So we depend on the data owners to provide that, and this has been an excellent tool for us to engage since the very beginning with them to capture such referential metadata.
All right, next is data quality. So data quality is a very broad topic and multidimensional. So unfortunately, just by using SDMX and SDMX tools, we are not able to address all of our data quality issues, but we're still able to tackle some of them systematically. And some of the benefits that come with that are pretty known, right? By using a specific DSD, data flow, specific set of code lists, we're able to leverage the FMR features and automatically validate our data sets to ensure that they're structurally sound and that all the values are present in the code list, etc. Another aspect that was really critical for us is automation. We're running more 150 plus data pipelines in productions that are orchestrated by Databricks. So it was really essential that we not only to be able to automate single pipelines, but also for that automation to scale across pipelines. So by leveraging SDMX as a standard, plus a package like PySDMX, which natively connect to SDMX APIs, understand the SDMX information model, we were able to build functions that are standard that we can leverage across pipelines. So it reduces the cognitive loads for people working on those pipelines across pipelines. Right? If I worked on one pipeline using that set of standard functions, I can go to other pipelines and understand what's going on very easily.
And then finally, at the end of our business process, we have publication and dissemination, where we have been using .stat for two final tasks, which is data owner review and approval of the data sets, and publication to either the API for user consumptions directly or any other further downstream platform development.
Thanks. And so to wrap up, really the SDMX ecosystem really empowered us to revamp our data infrastructure. And now that we've become an SDMX shop producing SDMX data in-house, we're really eager to contribute back to the community. And so in the pipeline, we have a few things. We're in the process of becoming member of the SICC community, and we're hoping that's going to be finalized pretty soon. As I mentioned earlier, we've used a lot of the PySDMX package to build wrapper functions that are closer to a business case. And so I'm hoping we can, through pull request, collaborate whenever that makes sense down the line. And finally, last but not least, the World Bank has developed an open source tool called the metadata editor that allows people to edit and manage referential metadata and export it in SDMX format that can be uploaded in any SDMX supported system. So there is a link here in the slide, so you can visit the page here. You can speak with Olivier Duprier here if you have more questions about the metadata editor. And finally, so we've really benefited from the SDMX ecosystem. We are eager to continue our SDMX journey. And I know it has been repeated many times already since the beginning, but I think it's worth repeating again. In our line of work, collaboration really beats competition. Thank you.
Our next speaker is Elisabetta Baldassari, and she's working at the statistical department in the Italy Marche region. And she will give us some insight in their use case of using SDMX in the ISTAT, with the ISTAT toolkit.
Thank you, Petra. Good morning to everybody. It's a pleasure to be here, and thanks to the organization for the invitations. And we will share, I try to share a concrete and replicable experience on the use of the innovative tools for statistical dissemination in line with the SDMX international standards. And we are the first region in the regional administration in Italy that is using the SDMX structure, in particular ISTA toolkit for the data dissemination and sharing, thanks to the collaboration with my co-authors that they are sitting in the seats there, and in particular Mr. Andrea Bruni from Italian Statistical Institute for the collaboration and technical and methodological support, and the IT department of ISTAT, and my colleague Sergio Carabellese, that it is responsible for the practical implementation and construction of the DSD in our statistical department. We, as a statistical department of a regional administration, we are taking part of the Italian statistical system, and the aim of our, I can say, objective, our objective is to improve the data dissemination and the transparency to help and to support, in general, regional policies and decisions makers and in general citizens. And what is the role of the Italian Statistical System Hub? We can say that the System Hub is a strategical tool that could allow statistical data to be published in SDMX format, ensuring in general standardization, interoperability, and public access. Marche region was adopted this ISTA toolkit, as I say, to improve the quality, the efficiency, and the transparency of data dissemination at regional level. Oh, sorry. What is the hub for Marche region? We can say that it is an operational response to the needs of a regional administration. And the aim of our statistical department is to improve the use of data, of the information in general, with different means. First, the publication of the data from Italian Statistical Institute and other organizations and bodies, the publication of microdata coming from ISTAT sample surveys and regional sample surveys at regional and sub-regional level, not available at the moment, for example, from Italian Statistical Institute to support the regional policies, and the data production of administrative sources at regional and sub-regional detail. Another very important means is the possibility to link the data residing on other nodes through SDMX web service, in particular with Italian Statistical Institute. What is the challenge? The challenge is to move, we can say, from a static dissemination mode to an interactive mode in a transparent and accessible mode, in line that it is important with the international standards and also the expectation in general of public users and citizens. What is the path that we follow to use and to implement the ISTA toolkit? In 2023, the Marco region joined the system project through a strict and efficient collaboration with the ISTAT. The software was installed, and then our working group, composed in particular from statisticians and some human resources skilled in IT, we follow the training, a specific training held by ISTAT, and then we continue to work independently, maintaining obviously regular exchange with ISTAT to receive support and assistance. And what kind of operational phases we follow? We summarize the main regional information needs. We identify the artifact necessary for the construction of DSD by different topics. We process data and loading. We define the different data flows and templates, and then we publish it on our market data browser. Some example of published topics: labor market, financial indicators, enterprise, other statistics concerning fisheries, waste statistics, all statistics produced at regional and sub-regional level. This is an example of the to pass from EMD manager to the publication in market data browser. And what results we have? The main results is to use a toolkit tested at international level. We use the internal human resources with few economic resources, and we try to improve in general the interaction with international, with the Italian Statistical Institute, and also with international organization to improve the use of the ISTA toolkit. Thank you for the attention.
We move now to the last presentation of this session. It's a presentation from the BIS. Matt Nelson and Stratos Nikoloutsos will take us on a time travel, especially for the SDMX metadata.
Thank you, Petra. Good morning, everyone. So, no AI models used in this presentation. Is plain and simple, no shiny stuff. It's a bit more technical, but we hope you find it useful. So, I'm here just to put the context from the business point of view. So, in the BIS, we're using our time travel enabled medal system, which is mainly a consolidated integration layer. So when we collect data, we have to ingest, archive, normalize, integrate data. All is good. Metadata is always SDMX in our case. But what's particular about medal is that data are always stored, never removed, and they are always accompanied by a timestamp. So it's a bitemporal system, so you can go back in time from the data point of view. But then, next to the data, we also have the metadata that follow this ingestion process, and this is where we also need this time travel. We also need the metadata to be able to travel back in time. So currently, medal is using a central FMR for its metadata. Of course, we couldn't be using something else, I guess. And of course, we need to go back in time because a user would like maybe to understand why a validation failed in the past. So he has to have the data that was ingested as well as the metadata, or maybe reconstruct an old submission using the original file as well as the metadata, right? So that's the main reason why we need the time travel in that context. And of course, for this, we haven't implemented that yet, but it's currently what we are working on. I think Matt will talk a bit more about how the FMR supports this. But the idea is that we want to use a new API feature of SDMX, which is the as-of parameter for metadata. So you can, at the moment, query, I mean, the standard specifies that you can query metadata at a specific point in time. And that's the objective from the medal point of view.
Thanks, Stratos. Yeah, so as Stratos mentioned, this is a new parameter of the SDMX API. So this isn't a tool specific thing. This is actually part of the SDMX specification. So I'm coming here with my TWG hat on to explain a little bit about how metadata time travel works with semantic versioning, which is also another part of the SDMX specification in version 3.0. So for those that are unfamiliar with semantic versioning, as I said, it was introduced in SDMX 3.0, and it's a way of letting metadata evolve without breaking the structures that depend on it. So here's an example of a simple data structure definition for CPI, Consumer Price Index, with 3 code lists. And you see the versioning number is 1.0.0. So semantic versioning uses a 3-part numbering strategy of major version, minor version, patch version. And in SDMX 3.0, it's possible to actually reference structures, not by the absolute version, but by the latest of something. So you can say, I want to use the latest minor release of the geo code list, or the latest minor release of the CPI code list. And what this allows is the code list to change over time and increase the version, and the data structure definition remains stable at version 1.0.0. So I'll show how this works in action. So as of January, the metadata looks like this. And then in February, we add a code to a CPI item code list. We add a communication code. And we increment the version number of the CPI item code list to 1.10. But you'll see the data structure definition for CPI remains the same. There's been no changes to this. And then another code gets added in March, and the code list moves to 1.2.0. So what we're seeing here is a kind of a graph of structures, where the nodes on the graph can change independently and update the versioning, but we have stability at the top of the graph. So semantic versioning is all about stability. And any of these code lists can change over time, as long as it's a minor change. So there are rules on semantic versioning which have been published, and it says things like, if you delete a code, that's a major change because it's a breaking change. So maybe just coming back to this slide, what we're seeing here is as the code lists are changing, of course, the rules are changing on what data we accept for the DSD. Because, of course, now we've added new codes to the code list, we can now accept more data in May than we could in January, because now we can accept data for education, communication, transport, and for different countries. But then we have this question, if the validation rules changed over time because we have new code lists, what did the graph look like at any given point in time? So what did the graph look like on the 15th of March, for example? And this is where the metadata time travel comes in, because it enables the system to simply ask for the metadata, for the DSD and the related structures at a point in time. And what you will see is the exact version numbers of each of the code lists that were used at that point in time and the references. And it's as simple as that. So basically, semantic versioning introduces the stability, the immutability, and the referential integrity, and metadata time travel then allows this contextual retrieval across time. So we should have probably put on the slide, actually, because we neglected to put on the slide that this as-of parameter. So the as-of parameter is part of the specification. You can go to the TWG REST API specification. You'll see the parameter there. Probably should have put that on the slide. We were talking about this just before the presentation. But also, for those that are interested and want to play with this feature, it's in FMR 12, which is in beta. Targeting a release of Q1 2026. And actually, for those that are coming to the capacity building on Thursday and Friday, FMR 12 is in the SDMX lab. This was presented yesterday by HMS. So you'll be able to look at the semantic versioning. And if you want to use the as-of feature, you can do that as well. It's kind of ready to go. So thank you for listening.
We have 6 minutes left for questions, so mics. We'll take them all at once and then we'll answer them. I think that's more efficient.
Hi, Jan Bourdieu, a geospatial lead from UNICEF. I have a quick question for Matt on the versioning of code lists. I'm particularly interested in versioning of the geo code lists. And this new feature of SDMX3, which allows us to store geospatial features. Is it also possible to version the geometries of geocode lists? Meaning that in the new version we have still maybe Spain or District A, but the boundary of this district has changed, which is often the case in the real life. Thanks so much.
Yes, thank you very much for this presentation, and I have also a question to Matt. So it's quite convincing to see how we can update code list. What if we need to add some code lists? I understand it's not the same process, but do you have a process to do this?
Yes. So from Sutong from ILO, also the question to Stratos and Matt. Just the question is, in the FMR, do you have the plan to say, for example, if you made a change in the code list, does this automatically change the number of the version to reflect? Because sometimes it's difficult to remember, like it's major or minor. So just a quick question. Yeah, thank you.
Thank you so much. Just a quick question to our colleague from World Bank on your SDMX journey. Do you have currently any SDMX endpoint that can be accessible for pulling data from WDA? Thank you.
Yeah, also a short question to the colleagues from the World Bank. You showed in your architecture graph that you're ingesting raw data, which is not SDMX, and then mapping it to SDMX. And I was interested in kind of what formats and how you do the mapping when you have this raw data stream that comes into your environment.
I have a question for the World Bank. What pushed you to develop the World Bank metadata editor? What are the main differences between your solution and FMR as an example? Thank you.
Okay, yeah, thanks for all the questions. Versioning of geocode lists, yes. So basically the geography of a code is part of the code itself. So you have a code ID and then the geography for that will be within the code. So the versioning is at the code list level. So if you want to describe a change to the geography, that's a new version. One thing I probably should have mentioned is that semantically version structures are immutable. You cannot change them without updating the version number. So that's what gives it the stability. I should have said that. On the question of adding code lists, So I think you mean, well, I'm interpreting that as kind of adding a code list to a DSD, maybe adding a new dimension to a DSD. So there's certain changes. There's a semantic versioning guideline which describes every single structure in SDMX and all the changes you can do. And the guideline then says this is a breaking change, and therefore it's a major version change, or it's a non-breaking change, in which case it's a minor. But this is a really interesting example because I have a presentation tomorrow with Abdullah exactly on this ability to modify the dimensionality of a DSD without breaking the upward chain for data collection. This is a feature of SDMX 3.1. Does the FMR automatically update the version number based on changes? So one thing it will do is it will enforce the immutability. You can't change the code list without updating the version number. Currently, the beta version does not automatically update it, but the guidelines are there, so we could, in theory, programmatically suggest the minimum version number that's required for the type of change that was made.
Thanks. So on SDMX endpoint for WDI, we do disseminate some WDI data in SDMX format, leveraging SDMX RI. For the rest of the data for the new infrastructure, for the moment it is internal only. It will be external in the coming months. On mapping from non-SDMX data into SDMX, right? That was your question. So we're basically leveraging FMR as well for that, creating basically dummy DSDs and creating a structure map for that, and then leveraging the same process, right? By SDMX reads the information, and then we automate the mapping. And then last question was about mapping. Oh, the metadata editor. So the metadata editor does more than SDMX. So it outputs referential metadata in multiple formats. So that's one of the key aspects of it, and there is probably more. So feel free to reach out to Olivier if you have more questions. Thanks.
So thank you, everybody. I will not take you too long because everybody is hungry, I guess. So it was interesting to learn that SDMX has a large field of application. It's not only disseminate data, but it's supporting the full flow of a statistical process, improving dissemination, we saw, improving the international compatibility was mentioned, also very specific use for the consumer confidence index supporting, and the surprise for me was the creation from the PDFs to an SDMX structure. Supporting regional policymakers is also very important. I understand your dream, Abdullah, but I also heard how important the community is. So I hope we can continue having these sessions. If all is AI, we don't meet again. Thank you.
Before we break for do we have a microphone? Yeah. Before we break for lunch, just a reminder for the members of the statistical working group. There is a side event during the lunch break. So it's the room that is right across this room. So yeah, for those of you that are in the statistical working group, join the others there. Otherwise, yeah, have a great lunch. I'll see you at 2 o'clock.